The difference quotient rule is a rule used to find out the derivative of a function. This is the rule. Limit of h approaches 0 of the function fx plus h minus fx over h. And the rule says that this expression is equal to the derivative of fx. In the previous lesson, we took an example of fx equals x squared, and we derived the derivative f prime written as f prime x to be equal to 2x using the difference quotient rule above. This was the example. We had fx equals x squared, and using the quotient rule, fx plus h minus fx over h as h approaches 0. We plugged in the value x squared, and we got out and simplified everything to be 2x plus h. As h approaches 0, here the limit, we're taking the limit of h approaches 0. This expression 2x plus h approaches 2x. So we found out that the derivative of the function fx is 2x. So f prime written as f prime x equals 2x. So this is a very simple example to illustrate the derivative. Today we will look at a more complicated example, a more realistic example, which you would encounter in your exams. More typical. Example is f of x equals x cubed plus 2x squared plus 4x. So the question we're trying to ask here is, what is f prime x? What is the derivative of this function fx? Okay, this is what we want to know. We will be using the difference quotient rule above and plugging in the value of this function fx and see how we can derive f prime x, the derivative of fx. You have to learn how to spell derivative, unlike me. D-E-R-I-V-A-T-I-V-E. Just learn it a couple times, you get it right. So taking this equation, the limit as h approaches 0, then we have f of x plus h. I'm going to write it in a different color just to emphasize that we had to plug in x plus h into the value minus f of x over h. So what we're doing is that we have this function twice over, and we are subtracting this function, plugging in x plus h with the same function but plugging in x only. So we're gonna write it out twice over, but the first time with x plus h plugged into these three variables, and the second time with x plus x itself only. Let me write it out for you. So we would be having x plus function of x plus h within here, plugged into here. So we have x plus h cubed plus 2x plus h squared plus 4x plus h. And then this minus would be here, and then you have fx itself, which would be x cubed plus 2x squared plus 4x. This whole thing is in brackets, so this whole thing is a negative, and the whole expression is divided by h. From here, let's expand this expression. I will expand x plus h cubed as x plus h squared multiplied by x plus h. I will expand it out in the next line, and then I'll expand 2x plus h as x plus h squared would be x squared plus 2xh plus h squared. Expand out 4xh as 4x plus 4h, and this expression is negative in front, so every single term becomes negative. So I get minus x cubed minus 2x squared minus 4x. The whole thing divided by h. Okay, let's expand out x plus h squared. I would get x squared plus 2xh plus h squared. We multiplied with x plus h in the next line, and then put 2 into this, expand this out into 2. So I would get 2x squared plus 4xh, 2 times 2 plus 2 times 2xh, so it will be 4xh plus 2h squared. I'll write this here, never mind. 4x plus 4h, 4x, 4h, and then I'll just copy this down, minus x cubed minus 2x squared minus 4x. This whole expression divided by h. Next line, let's further expand out this expression with this expression. So I get x squared times x, which is x cubed, plus x squared times h, which is x squared h, plus 2xh times x, which is 2x squared h, plus 2xh squared, 2xh squared, plus h squared x. I'll write it as xh squared. I always like to write the x first, so it makes it easier to cancel out like terms. And then h squared times h is h cubed. And this, whatever follows here, is just copied out. So I'll just copy it out. plus 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus x cubed minus 2x cubed minus 4x minus 2x squared. Okay, x cubed minus 2x squared minus 4x. Okay, when we have this, we can in fact simplify if we look for similar terms. Let's start. X cubed minus x cubed, so this goes out. X squared h plus 2x squared h, so I get 3x squared h. Two x h squared plus x h squared, so I get 3xh squared. H cubed, there's nothing that matches h cubed, so I'll just write it straight below. X squared minus 2x squared, so this cancels out. Plus 4xh to h squared (4x minus 4x), so cancels out, and then the last term is plus 4h. I'm using pink for illustration purposes, but when you're doing it in an exam or a test, you will be using a pencil and you can do it very much quicker than I can. But the idea is to cancel out like terms, and when you write something down, you just give it an underline so that you know you've taken care of it and you wouldn't double count. I'll remove this page, push this up. Divide by h. What is happening now is that we have the limit as h approaches 0 to this expression, and we are trying to simplify this expression a little bit more. And if you look at this expression, you will see that h is a common term in every single h is a common variable in every single term. So in fact, I can factor out h. So I would get 3x squared, and h is factored out, so I'll get 3x squared. One of the h is factored out, so I get 3xh. This here would be h squared. This here would be, the h is factored out, so I'm left with 4x. This one I'm left with 2h, and this one I'm left with 4. So this whole thing divided by h. So we can see here that h also cancels out. What am I left with? I'm left with this equation, 3x squared plus 3xh plus h squared plus 4x plus 2h plus 4. If you look at our difference quotient rule, what we are saying here is that as h approaches 0, we want to find out what happens to this function, and that is equal to the derivative. So what I can actually say is that I can make the claim that as h approaches 0, any expression with h also approaches 0 and actually becomes 0. So taking this expression, if h approaches 0, this whole expression can be taken out and it could be equivalent to 0. This is 0. This is 0. So this and this can be taken out, and we are left with the result. Excuse me. Equals 3x squared plus 4x plus 4. And the difference quotient rule says that this is equal to the derivative of f of x, f prime x. The function fx is equal to x cubed plus 2x squared plus 4x. For those of you who don't know calculus, we will find out in later lessons that we can easily find the derivative of a polynomial like this by multiplying. Example x, you multiply it by in front by 3 and then you subtract 1 power, so the derivative of x cubed would be 3x squared, and same thing, you multiply 2x squared by 2 and then subtract 1 power, so it becomes 4x. And this same thing, the x to the power 1, you multiply 1 by 4 and you subtract, it becomes x to the power 0, so this whole expression becomes 4. So in fact, the derivative would be 3x squared plus 4x plus 4, which matches the derivative if we were to use normal differentiation techniques. But for our purposes today, we are finding out from first principles using the difference quotient rule, and the algebra is complicated, but it's something which is good to know, and you have to know it, and you will be tested in it during your exams. So you have to learn how to do the algebra and learn how to set up the equation properly. Set up the equation properly so that you can, I have the function, I have the rule, and then I set up the equation properly, and then I work through the algebra and I get the result. Thanks for listening. See you next lesson.